Hi, everybody. Hopefully you're doing well. Once again, it's time for me to do this exam again. So we're going to go right into this. I'm not going to, save anything or do anything. It's just me doing the practice exam again. And I will be watching the chat to see what you guys have to say. And every so often, having some fun here. So, sit back, relax. You can help me answer some of these questions so I can get them drilled in my head so I remember the answers. So when I'm ready to write this exam, I'm ready for it. Let's face it, the exam is not the most easiest exam. There's 100 questions for the Canadian exam, and it does take a lot of work to get through this. But like I said, I'm going to go into this. Let's have some fun. Let's get into this. And this is also good for you guys because if you ever want to do this exam, then you know what you can expect from doing a Canadian exam, and we all can have some fun with this. So anyway, starting off with the first question. What type of stations transmit one-way communication? A VHF station, XHF station, beacon station, or repeater station? Well, we know a VHF station is can be back and forth. We know HF can be transmit and receive. We know a repeater station repeats everything. So technically it could be, but no, it doesn't fall into one-way transmission. That would fall under a beacon station because a beacon sends out a signal at one time. So we'll go C and go submit. And C is correct. On to the next question. Practice exam number 2. In a 3-element Yagi, directional antenna is the blank longest radiating element. So the directional antenna. On a directional antenna, the back end is going to be the longest. So is that the director, the driven, the boom, or the reflector? Now, when you're beaming signals, you want to concentrate on the center driven element. So we know it's not the driven element. The boom, that's the pole that holds it. That does not count. A director is the front end of that Yagi, which allows you to direct your signal. So the signal will be directed into it. So the reflector, because what the reflector does beams the signal back towards the element. So it's D, the reflector. And the reflector is at the end of the antenna to direct the signal. So yeah, D is correct. So how you all doing? Hopefully you're having fun. And, if you want to say something in chat, let me know that you're there. It's the only way I know who's watching. So going on to the next one. In an amateur digital radio system, the modem function is often performed by the computer blank. Is that by the scanner, serial port, keyboard, or sound card? So if you guys remember digital... the back in the old days when we used to have to phone into the internet and you hear that. Well, those radio signals don't sound the same way. Using stuff like RTTY. It has this and then you have your JST call, which those are all audio. And for the computer to communicate over HF, it has to put out some type of sound. So we know it's not a scanner. We know it's not a serial port. We definitely know it's not a keyboard. So it has to be a sound card. D is correct, sound card. Here's one that gets a lot of people confused. And honestly, it can be a little confusing because we have 2 parts of the amateur radio, if I remember correctly, what they're asking for. Which of the following provisions is of the ITU radio regulations apply to Canadian radio amateurs? He's saying D. Okay, well, let's have a look. Administration shall take such measures as they judge necessary to verify the operation of technical qualified amateurs. Radio communication between countries shall be forbidden if the administration is one of the countries objects. Okay. C, it's forbidden to transmit international messages on behalf of third parties unless those countries make special arrangements. D, Transmission between countries shall not include any messages of technical nature or remarks of a personal character. D sounds right. But if I remember correctly, I know there's something about forbidden transmission. Oh, is not. Okay. So yeah, A, B, and C is definitely in there. But I've never heard of the professional character system. So I'm going to say D. I agree with you. D is probably the right one, Bruno. So let's submit it. And D is correct. Next. Which two electrical units multiplied together giving you units of watt? Voltage in amps, amps and henries, fade in henries, volts and farads. Volts and amplimeters and henries. This is where ohms and power law come into play. If I remember correctly, I believe the answer is A. But I'm not 100% sure because it's been around. Like I said, I haven't looked at this in a long time. Everybody's saying A. Okay, let's see what happens. A is correct. Thanks, Bruno. And also 3D Medic Vince, thanks for answering it also. A. Like I said, my electrical knowledge is not that great, but you throw an engine in front of me, I can fix it. So, like I said, knowledge and working with the parts versus, this. But anyways, let's get into the next question. Which of the following is not an exception from the penalties under the Act of indulging, intercepting, or using information obtained through radio communication other than broadcasting? Where behalf of Canada and for the purpose of international or national defense or security, where providing information to a journalist, where it's for the purpose of preserving, protecting property, or preventing harm to a person, I should say. Whether the purpose of giving evidence is in criminal, civils, blah, 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 blah. Yeah. Is not an exception for penalties. I remember something about journalism that we weren't supposed to do that. So I'm going to have to say it might be B. I'm going to go with B. B sounds right. And B is correct. So in our Canadian laws, we have something against journalism that we can't provide information to a journalist under the Information Act of Canada. I don't understand it personally myself, but it is a law. So, which of the following describes a full break in telegraphy, or QST? Break station sends the Morse code prosign BK, break. Automatic keyers are used to send Morse code instead of a hankies. Okay. Operator must activate manual send and receive switches before and after every transmission. Incoming signals are received between transmission Morse code dots and dashes. Okay. Full break. This is a fun one. This is something with Morse code. I'm not really good with my Morse code information. But if I remember correctly, I think BK is the break that we use, like short BK means break or something like that. I think that's what they're asking for. We'll find out. No, they're looking for D. Incoming signals are received between transmit Morse code dots and dashes. Okay, well, we know Morse code is dot and dashes, but that doesn't describe the full break in telegraphy. Somehow it's the answer. That's a weird one. On to the next one. If you are operating simplex on a repeater frequency, why would it be good amateur practice to change to another frequency? Well, there's many different rules to this, but let's go with the right answer that they're looking for. A, the repeater output power may ruin your station's receiver. Changing the repeater frequency is not practical. There are more repeaters operation than simplex operators. Changing repeater frequency requires authorization of the involved sciences and economic development of Canada. Good question. If you're operating on simplex on a repeater frequency, why would it be good practice to change to another frequency? The repeater output power may ruin your radio station receiver. That's not really true. Changing repeater frequency is not practical. That is 100% the answer. You can't. I don't know if it has to be registered with Ontario, but I'm going to say changing the repeater frequency is not practical. Because all this stuff is like posted and everything else. So I'm going to go with B. And B is the correct answer. Next. So, we're on to 9 now. Of the components of AHF station, which component normally connected closest to the antenna tuner, and dummy load? A low-pass filter, an SWR bridge, antenna switch, or D, a transceiver? Oh boy. And that's my printer going off. Back in a second. I'm sorry about that, guys. I had to go and change the filament in one of my machines, which is printing a sign. If you guys don't already know, I do 3D printing of call signs. So if you're interested in one, check out my other videos and let me know if you're interested. Anyways, going to have that site up soon, hopefully within the next week or so. It's just been busy. So as we were looking at it, so the components in the HS station, which would normally connect to the closest of the antenna tuner, and dummy load. So is a low pass filter? No. SWR bridge? Definitely not. Transceiver sounds right, but I'm not sure if that's what they're looking for. I think they're looking for an antenna switch, actually. Got me thinking C. I know some people think B, but I'm thinking C, antenna switch. Yep, C is the correct answer. That's what they were looking for. So an antenna switch, what that's for is for switching different modes of antenna. So instead, an antenna tuner and dummy load. I know dummy load is a load that we would send your signal through your antenna transceiver into the dummy load. That first got me thinking dummy load. Got me thinking antenna switch is what they were looking for. They said the antenna tuner. Now an antenna tuner is usually connected to the antenna itself, and then vice versa goes through the antenna switch. So that's the way I thought about it there. So next. Units in decibels is used to indicate. Okay, so in decibels, we usually use that for sound, is the way I've always been taught. But in here, it has a different meaning altogether. So, certain radio waves, a mathematical ratio, a signal sideband signal, an oscilloscopic waveform. Oscilloscope waveform. Now, sound is measured in waves, which gives you the decibels. I'm starting to think this is going to oscillate waveform is what I'm looking for. Certain radio waves, they don't do decibels in wave, but it can be calculated that way too. But I'm leaning more towards this, D. It feels right. So I'm going to go with D. I've always been told, go with your first gut answer that feels right and just go with it. Because 9 out of 10 times, if you overthink it, then you kind of may pick the wrong move. So we're going to go with D and see what happens. If I get it wrong, it's not the end of the world, but it's good to know these things so that next time I see this question again, I remember what the answer would be. And actually, it's B. They were looking for mathematics here. Okay, well, it's always good to know. During Club ARR Field Day, outgoing reception on 20 meters SSB single sideband station is compromised every time the 20 meters CW station is on the air. What might cause such interference? Now, here's where it comes into fun play, because we're going to be looking at, we got two stations side by side, away from each other, but they're causing interference with each other. There's a reason for that. So let's have a look at this. Is it A, improper station grounding? B, receivers desensitized? C, harmonic radiation? Or B, both stations are fed from the same generator? Well, we know B is totally bogus. The both stations are fed from the same generator. That's D is bogus. A, improper grounding, station grounding? No, that wouldn't cause signal interference. Harmonic radiation, C, it could, but they're broadcasting on totally two different stations. What's happening is receiver desensitization. So, say if me and another guy were close to each other and we were on our 2 meter radios. Where's my 2 meter? Who cares where it is? But anyways, if me and the person are in the same area, broadcasting in the same area, we can desensitize our radios so our radios don't hear each other. So B is the right answer. That's correct. So to say hi to everybody, hopefully you are all watching. 3D Medic Events, how you doing? Hopefully you're doing well. Bruin Nerves, thank you for joining us. And to anybody else that's watching that has not said hi, thank you so much for joining us. Today we're looking at the practice exam for the Canadian exam. I am doing this just to test my knowledge and to get my knowledge back up to a standard where I feel comfortable enough to rewrite my exam so I can get my HF privileges. This means I can broadcast at higher frequencies. Right now, all I can broadcast is at 2 meters, 70 centimeters, and that's it. So what I'm working on is to be able to use this more often. This is my HF rig. This is the Zylu G90. I've done a few changes to this. I printed out a new knob for tuning in because the other knob was just awful. And a foot stand so I can stand it up while I'm in a park. And most of this HF stuff that I do is going to be in park broadcasting. So we need to do this test again so I can get that done. So hopefully you are enjoying this. I want to thank you all for watching. So let's get back into the questions. Oops, I just streamed. Thank you. Okay, maximum percentage in modulation permits the use of radiotopography by an amateur radio station is A, 90%, C, 75%, C, 100%, or D, 50%. If I remember correctly, it's C, 100%. We're allowed 100% of our power that we're supplied by, if I remember correctly, of this all. Let's see what happens. Submit. C is the correct answer. It just didn't sound like any other answer. Okay. Now, here's where we get into some circuitry fun. A coil and an airspace capacitor are arranged to form a resonant circuit. The resonant circuit's frequency will remain the same if we insert a Mylar sheet between the plastics and capacitors, add a resistor to the circuit, wind more turns in the coil, increase the area plates of the capacitor. Coil and an airspace capacitor are arranged to form a resonant circuit. This will remain the same if we add a resistor to the circuit or the winding coil. Well, we don't want to add more winds to the coil. The coil is already the resonating, would give it that. So adding a resistor to the circuit would allow that area to, I think it's B if I remember correctly. Yep, B is the correct answer. So if any of you guys already have your licenses, if you want to put it down, if you have your license, love to know your call sign. I know 3D Medic Vince, I don't think you have a call sign. I don't think you're an amateur radio operator as of yet, if I remember correctly. Bruin Nerves, I'm not sure if you have your call sign yet or not. But if you have a call sign, hey, place it down. Love to know more. Anyways, let's go into the more questions. What's inside the envelope of a tryotube? Neons, argon, vacuum, or air? If I remember correctly, it's a vacuum that forms the tube. Yep, C's correct. Oh, you do have a call sign. I didn't know that, Vince. Congratulations. Didn't know you were part of the... I thought you were... I didn't know you had a call sign. Congrats, dude. Hopefully one day we're able to, trade some QSL. QST. No, not QST. QSL. Yeah. I'm losing it today. It's been a long day. What can I say? A Canadian amateur radio operating his station 7 kilometers, 4 miles offshore from the coast of Florida is subject to which frequency band limits? Those applicable to the Canadian radio amateur, those applicable to the U.S. Amateur, ITU Region 2 or ITU Region 1. States is Region 1. This is actually a answer in one of the books where they talk about the reason for this. I'm trying to remember what the answer was. I think because I selected U.S., it said no because those are applicable to Canadian amateur radioists. I want to say probably it's A. That's the first answer that comes to my mind, but I could be wrong. Could be Region 1. But let's have a look. It's B. Those applicable to U.S. amateurs. That is interesting. Okay, now I know that. Next. In Canada, 10-meter amateur radio band corresponds to frequencies to, 10 meters. I'm not really good with my 10-meter information. 24,890 to 24,990. 21 to 2450, 28 to 2970, 50 to 54. Okay. 6 meters is 50 to 54. I know that much. I'm going to say probably C. Yes. $17. When two 500 ohm 1 watt resistors are connected in parallel, they can displace the maximum total of, this is where I really suck at this stuff. Two 500 ohms, 1 watt resistor connected in parallel. So parallel would divide the powers by 1. I want to say A. A is just sounding right. A is correct. So it's 2 watts. Single sideband transmission of the blank is between the balance modulator and mixer. This is the ones I really hate. Is it a speech amplifier, radio frequency oscillator, microphone, or filter? Balance modulator and mixer. I want to say radio frequency oscillator. Let's go with B. Feeling's not right, but let's submit it. It's not. It is D, filter. So remember that if you see that question. Between balance modulator and mixer, it's going to be B, D, the filter. So in the amateur radio book, which I don't have in front of me, there are maps that we have drawn out explaining what parts that we would need in between each part, which can get really confusing at times because when you look at it, you're just going, B or D, So let's go on to the next one. Practice 19. Okay, here we go. What should be done if proper operation of amateur radio station is a cause of interference to a nearby telephone? Okay, this can be kind of questionable, but let's have a look into this. Install a modular plug-in telephone RFI filter to close the telephone device. Make sure internal adjustments to the telephone equipment. Stop transmitting whenever the telephone's in use. Ground and shield the local telephone distribution amplifier. Now, if I remember correctly, it's going to be the RFI filter. I know it sounds weird, but that's what I think it's the answer. And I am correct. Hey, Andy, thanks for coming on in. How you doing, buddy? Hopefully you've been doing well. Andy is also a amateur radio operator in the UK, if I remember correctly, right, Andy? And also I've been seeing him on with Larry over at Ham Radio Live, which is a live amateur radio show. You know, the guy does amateur radio, talks about 2 meters, talks about all these types of quizzes, this type of stuff also, similar to what I'm doing. But also he is, he does CQ calling show, where he calls out on, I believe it's 40 meters he's been lately playing on, but 20 meters is also good too, as we all know. And makes calls out and sees if he can get people. And see if we can get talking about some amateur radio and the joys of what brought them into amateur radio. So it's a lot of fun to watch that. And yeah, so if you want to watch some really cool stuff, check them out. Ham Radio Live. Ham Radio. Yeah, it's Ham Radio Live, right, Andy? I think so. Yeah, it's Ham Radio Live. No, and Andy Hill probably correct me if I did say it wrong. Yeah, I'll look that up in a few minutes. So let's go on to the next question. And thanks for joining us, Andy. I do appreciate it. Why do modern HF transmitters have a built-in low-pass filter in their RF output circuit? To reduce harmonic radiation, to reduce fundamental radiation, to reduce RF energy below the cutoff point, to reduce frequency interference to other amateurs. Built-in low-pass filters is basically to filter out noise or other types of harmful stuff. So I'm going to say not harmonic radiation, but it may be to reduce not RF energy. Low frequency interference from other amateurs is what I'm thinking D is. Let's have a look. No, it's to reduce harmonic radiation. I was wrong. Okay. That's an interesting question. I don't think I've ever ran into that question before. Which two types of radiation from the sun influence propagation? Now, this is a fun little thing because right now we are in sun cycles right now. And if you ever thought, well, why would I want to get my amateur radio license? This is one reason. We're going into the best years of amateur radio. This is a time when you can hear stations far enough away and make some amazing contacts. Whoever thought you'd pick up a radio, call CQ, and you would hear a station like, oh, I don't know. You'll hear the VK stations come out. That's Australia. That is Australia, and I want to say India. I've been hearing stations I've never heard in my lifetime coming in right now. The bands are opening up right now. This is the greatest time to get out and get your HF. If you don't have your HF already, recommend you go look at HF. It is worth it. That is getting your general. And then, so in the States, you guys have 3 exams. You got your general, you got your advanced. So you got your general, you got your technician, general, then advanced. Canada, we only have 2 of them. We have our regular basic, and then we have our advanced. Our basic allows you to use all HF, all 2 meters, 70 centimeters, the whole 9 yards. The other blank, which is advanced or what we call advanced, allows us more power, allows us to build radios to use on frequency. So yeah, you can do a lot with your advanced license. But you're not limited like in the States do, where you're only limited to so much on general, then you have to have your advanced to go more. I'm not sure if that's the same for you, Andy, in the UK. Correct me if I'm wrong, but yeah, with my license, because I scored so low in the exam, I don't get the extra. I don't get the HF. So this is all me rewriting the basic to get that HF. So keep in mind, you can rewrite your test even if you passed it. So, but will I do the advance? Probably I will be doing the advance. Just don't know when. Okay, so here we go. Which two types of radiation from the sun influence propagation? Substantial and audio frequency emissions, infrared and gamma rays, electromagnetic and particle emissions, polar region and equatorial emissions. Well, that doesn't sound right at all. Polar does not affect the ionosphere. Subterrant and audio frequency emission does not sound right either. Sounds something weird, and I'm not even sure how that would affect. Infrared and gamma rays. We're not close to that sun. So it has to be C. Electromagnetics and particle emissions affect the ionosphere. So we're going to go with C here. C is the correct answer. With the Canadian exam or any of the American, and I don't know how it is in the UK, maybe Andy can answer me. Andy, is the UK exam multiple question also? Just out of curiosity. We'll go to the next question while I wait for Andy's response because, well, I'm delayed. So, in a CW transmitter, the output of the blank is connected to the driver buffer. I hate these questions. Is it the powered amplifier, the master oscillator, the telegraph key, or the power supply? Now, we're given a clue here. CW transmitter. So we know maybe it could be the telegraph key. Power amplifier, I don't think drives the buffer, if I remember correctly. The master oscillator. No. Output. So we're sending a signal input. The only thing that allows me to send a signal into would be the telegraph key. I think this is what they're looking for. Could be wrong, but let's submit it and find out. They're looking for B, the master oscillator. Oh, yeah, I'm not showing it to you guys. Sorry. Let me pull that in. Come on, do that. Nope. That's the one I wanted. Sorry, guys. I do apologize. I thought I hit the button. Hey, thanks, Andy, for the answer. So, yeah, multiple questions. And how many questions is it for you guys? Is it only 25 or is it 100 like we have to do out here in Canada? Okay, so a permanent magnet would be most likely made of blank. So is it steel, brass, aluminum, or copper? Okay, well, we know it's not copper because it's a silver color. So it could be either steel or aluminum. We just cut brass and copper out of there. Aluminum, if I remember correctly, is not that magnetic. It doesn't have a lot of magnetic properties. I'm going to say it's steel. Steel just sounds right. A is correct. Next. What emission type does the instantaneous amplifier envelope of an RF signal vary in accordance to the modular audio? Oh, phooey. One of those questions again. Oh, I hate these questions. So enveloping in the RF signal with modulation audio. Frequency modulation, amplitude modulation, frequency shifting key, or pulse modulation. Pulse modulation is when you're doing Morse code, so I doubt it's pulse. I don't think it's frequency modulation. Amplitude modulation sounds right, but I'm not 100% sure on this one. I don't think it's a frequency shifting keying. Okay, so I'm going to go out on a limb. I'm going to say amplitude modification. B is correct. Whew. What municipality has developed public consultation process? Which of the following options best describe all circumstances when public consultation may not be required? This is a fun one. This is one of those trick 22 questions that we've all experienced before in an exam where it'll be like, oh, what do you mean we have to do this? So let's have a look at this. Okay, so if I remember, I believe this includes the list of the sciences and communication. This is like the head of Canada's communication board. I'm just going to go on a limb and say it's D. Exclusion list of the innovation sciences, development of Canada procedures on radio communicated broadcast antenna system CPC-2-0-03. Oh, you're looking for B. Exclusion listed either in CPC-2-0.03 or local land use authority process. Okay, here we go. To make your call sign better understood, when using voice transmission, what should you do? Talk louder. Use standard international phonetics for each letter of your call sign. Turn up your microphone gain. Or D. Use any words to start with the same letter as your call sign for each letter you call. So with my call sign VA3FUC, that would be Victor, Alpha 3, Foxtrot, Uniform Charlie. Those are the standard international phonetics for each of your call sign, for each letter from my call sign. So it'd be B. All right. I noticed that Vince gave me B, so B bravo. Bravo. Or beta in that case. Why is FM voice best for local UHF and VHF coverage? It's more resistant to distortion caused by reflected signals. Its RF carries steady on a frequency, which is better than the AM modes. The carrier is not acceptable. It provides good signal plus noise ratio and RF signals are levels. Now, if I remember correctly, not more resistant to distortion. And C, the carrier is not deflectable. There's low RF in usually 2 meters, 70 centimeters. That's VHF and UHF. So I'm going to say D is probably the answer they're looking for. Yep, D is the correct answer. Low noise. Okay, let's see what we can do this. A length of metal is connected in a circuit and is found to conduct electricity very well. It would be best described as having A, low wattage, B, high resistance, C, low resistance, or D, high wattage. Well, if energy can flow through the metal very well, that means it has a low resistance to deflect the signal. So I'm going to say C, low resistance. Think of it like water, okay? So water goes flowing down a creek, okay? So it's going over rocks and everything else. It hits this wall. It divides itself because it can't go around that area, so the water flows around it. In turn, it slows down all the water speed. So, 2, that is giving it resistance. Like energy, it flows a similar way. If it hits something, it needs to disperse, but you're not giving it more power behind it, so it loses energy, making it causing a resistance. But if energy can flow through an area and out the other way and causing no loss, that is considered to be low resistance. Which of the following statement is not correct? Okay, so we're looking for the wrong one. Okay, so a disability candidate must pass a normal amateur radio exam certification before being granted any qualifications. A disabled candidate taking Morse code send test may be allowed to recite the examination and test with Morse code sounds. D. Examination for a disabled candidate may be given orally and tailored to the candidate's ability to complete the exam. An accredited examiner must recover the costs of admitting the exam. So, a disabled candidate must pass a normal amateur radio certification exam before being granted any qualifications. So saying that person has to finish the exam. I get that. A disability candidate can be allowed to recite examination tests in Morse code sounds. Okay. Examination for disabled candidates may be given tailored oral. Yeah, that's allowed. Credit examiner must recover the fees for examination. Now, some examiners may charge money for that, but I'm going to say probably D is the wrong answer. A. Okay. So a disabled candidate must pass a normal amateur radio certificate examination before being granted any qualifications. Now, with this wording, it can be a little off because I would think when they mean disabled, do they mean that the person can't write and was given it to them orally? Well, that makes sense. Right now, I'm doing the exam. So this is the exam for the Canadian Amateur Radio examination. So that's what I'm doing right now. Not playing radios tonight, unfortunately. Sorry, Baked and Wake. But in here, this is kind of interesting the way that they're wording this. From what I know, disabled still have to write the same exams as we do. But are they saying before they grant any qualifications? Like they would have to still pass to give them the examination. I must be reading a little bit into this. That's what I can tell. But I always thought that the examiners are not allowed to they're not allowed to recover any costs, if I remember correctly. But then again, I could have that mixed up with something else. But yeah. What effective response for propagation in UHF is signals over 800 kilometers or 500 miles? Faraday rotation, tropospheric ducting, moon bounce, EME, moon Earth, Earth moon Earth, or D, regional aspirations. Isotropic inducting can do that because we're coming into spring now, and this is when we can get some really cool stuff going on. I've heard stations as far away as Iowa getting into our repeater and having conversations with people in the States over 2 meters. Analog, not digital. This is analog. Because the signal got into a ducting and it just got carried. Weak, but got carried. It's kind of funky when it happens. So let's see. I think it's D, if I remember. B, if I remember correctly. It's isotropic ducting. Yes. So where I live in southern Ontario. So you look on a map for KW. We're like an hour outside of Toronto. I was hearing a station in Chicago. We could hear some US guys coming through. We're surprised that they could hear us. They came into our net when we were doing a net. And oh man, it was awesome just hearing these stations come in because we said, go right away. Because we're not sure how long we're going to have you. Said Beast was happy to, be able to hear us and was enjoying our net. And then we lost them. We didn't hear back from them. So yeah, it can be a lot of fun when you get that type of stuff going on. Oh, congratulations. How you liking the Alliance HD1? Hopefully it's proving to be a good radio for you there, Big. Let me just put that up so people can see it. So we're going to go to the next question. I might actually grab myself another drink, though. Why would you use a dummy load? Okay, now this is kind of interesting. So dummy loads, what they are is just a big giant resistor. It's faster to tune. It gives a comparative signal report to test and adjust your transceiver without causing interference, or D, to reduce power output. The idea of a dummy load is to contain your signal, not let it get out there. And if you're doing like any tuning or prepping or working with your radio, it's very good to put it through a dummy load. So to test and adjust your transceiver without causing interference is the answer we're looking for. And that's what a dummy load allows you to do. So we're going to say C, to adjust in a receiver. Going to be a learning curve for sure. I've been watching your stuff on. Oh, cool. Well, hopefully it works out for you. Hopefully you can get licensed. I don't know if you're in Canada or the U.S., but the U.S. exam is a little bit different from the Canadian exam. So let me go full screen here again. So with the American exam is 36 questions. Now you can take those exam questions through the FCC. I think you got to go to the FCC, then the AWRL, then you can do a practice exam for your license. For Canada, we got to go through the Canadian government and do their practice exam. It's 100 questions. But what I like about our exam is it breaks it down to areas where you're weak in. And then you just go back through the book and just reread those over and over again until stuff sticks. And you can also do just questions from that area so that you get better at answering those questions. It's actually, the Canadian exam has a lot of little loops that actually help you get better at this stuff. So something to think about if you need to write the American, the AWRL, and the FCC. Now I believe Andy is going to say there's one for the UK also. Is UK the Ofcom? Do you go through Ofcom or do you go through the GBRL? Just out of curiosity. So we're going to go back to our regular screen. There we go. Next. 32. Why is the Yagi antenna often used for radio communication on 20 meters? This is a very good question. Ah, cool. So your call sign's KJ7WOK. Cool. That's interesting. My friend's call sign right now, he lives in Texas, name's Al. He is working on getting his general also. I know it's a lot of work to do, but all the best to you. I hope you get it because it's a lot of fun. Oh, okay. So you went through. Okay, I'm in Western WA, so I'm ARL. Went through the GLAARG for my test. Well, hey, congratulations, anyways, for passing the test. It's a hard test to pass. I understand that. So we're looking at why is a Yagi antenna often used for radio communications of 20-meter band. Provides excellent omnidirectional coverage in a horizontal plane. It provides the possibility of angle radiation for HF bands. Helps reduce interference from other radio stations off the side or behind. It's the smaller, expensive, and easier to erect than a dipole or vertical antenna. Well, definitely it's not D. I've helped people set up their Yagis. It's not D. I know that for a fact. Interference from other stations from off to the side and behind. Well, a Yagi is directional. So we know omnidirectional is not an option. Provides the highest possible angle of radiation for HF bands. It could. But I believe it is C, if I remember correctly, helps reduce. So let's go and see what answer it is going to be. C is the correct answer. So a Yagi has your short beam, middle beam, and then a large beam. And what it is meant is you have your director, driven element, and reflector. So if the signal is coming this way and it hits your back reflector, it gets driven to the element. The front element drives the signal into the driven element. So that's how the whole idea of a Yagi works. Voltage required to force a current of 4.4 ampemeters through resistance of a 50 ohms is, okay, 220 volts, 22.0 volts, 0.220 volts, or 220 volts? This I know I'm going to get wrong, but I'm going to take a wild guess. This is telling me, I really feel strongly it's going to be C, but I have a feeling I'm wrong, but we'll see and find out. D, 220 volts of power. Like I said, my math is not my greatest strength, so what is? Okay, this is kind of interesting. Voltage regulation is the principal application of the junction diode, zenith diode, light emitting diode, or vacuum diode. Well, light emitting diode would be like if you were doing it in a section of to draw less power. So I don't think it's light. Junction diode doesn't sound right. I don't think it's vacuum. I'm going to go with B. Take a wild guess on this one, but I have a feeling that's the diode they're looking for. It is correct. Okay. Okay, so in a typical single sideband phone transmitter, what circuit processes signal from a balanced modulation and sends the signal to the mixer? Is it the carrier oscillator, the IF amplifier, the RF amplifier, or A, the filter? So we got a balanced modulation coming into signal going to the mixer. The answer feels like it would be filter. And the reason I say filter is we ran into questions similar to this that said it was a filter. But I'm kind of leaning towards the carrier oscillator now. Yeah, I'm going to go with carrier. Let's go with carrier oscillator. No, it's the filter. Should have gone with the way it sounded, right, guys? Should have gone with the oscillator. Should have gone with the filter. Oh well. Communication on an 80-meter band is generally most difficult during daytime in summer, evening in winter, daytime in winter, or evening in summer. Maybe, Vince, you may be right. Okay, 80 meters is usually available during nighttime. It is what we call the CBers of radio. Evening during the winter, I would think is the most easiest because we get the most night sky. So, not a lot of problems for 80 meters to be where the F bands are considered, where these F1 and F2 in the atmosphere. Daytime in summer sounds about right because we got so much light and heat would affect the ionosphere. Daytime in winter would be difficult, but also doesn't make sense. Evening and summer, darker might be harder to hear it, but I don't think that would affect like daytime in the summer. So we're going to go daytime in the summer. So when we have most sunlight, we have a couple layers. You got the D, the E, and the F layer. Depending on what you're seeing, how the ionosphere is, you balancing your signals off the ionosphere and back down. So when you're sending off a signal and it's bright outside, the F becomes a little bit more bounceable. If I remember correctly, the signal just gets absorbed by the ionosphere. Where darker, the signal can go up higher and bounce back down, but not be absorbed by the ionosphere. If I'm remembering remembering how it all works. And I believe when it becomes F1 and F2, that's when the ionosphere absorbs or allows the signal to escape and not return back to Earth, causing that phenomenon where 80 meters just doesn't work. And yeah, heat does have a lot to do with it also. But the solar radiation is where it all comes into play. Okay, so we're talking about scatter mode. So backscatter, inverted scatter, forward scattered, or side scattered. Backscatter is a scatter type. I've heard of it before. Forward scatter. Side scatter. Inverted scatter. I think it's inverted scatter, if I remember correctly. Yeah, it's inverted scatter. During disaster, only use frequencies in the 80 meters band. Use frequency in the 40 meter band. C. Most communication are handled by nets. Predetermined frequency in the amateur band. Operators do not directly involved in disaster communication are requested to avoid making unnecessary transmissions on or near the frequency used for disaster communication. Or D. United Nations approved frequencies. Well, when a disaster hits, nets go into action. And if you're not part of the disaster, they ask you do not interfere with their disaster relief. So it will be C. Final answer. C is correct. I need an applaud machine here. Just go, woo, yeah, woo, yeah. Something like that. Oh, well, I'm going to grab a drink. I'll be right back. But if you're interested, if you want to help, that's a way that you can do. I have a PayPal account. You can go to PayPal.me/CMPVA3FUC. If you want to donate a few bucks, you're welcome to do that. Not needed, not requesting it, but you have that option. Or you can send it to my, where is it? That's not the one. Hide. Show. This is just my Patreon for my Canadian Maker project. This is when I do like 3D printing, talking about 3D printing. Streamlabs Canadian Maker project also will help too. Those are just other ways that you guys can support this channel also. But I don't look for support, so just give you guys an idea. I'm going to leave this answer up a little bit. I'm just going to walk away for a few seconds, just grab something to drink, and I'll be right back. Hey guys, I'm back. So sorry about that. I have a sick cat, so I had to feed him some medicine and such. So it's a pain in the butt to get it into his body, but it is what it is. So let me go back to my regular view. Okay, there we go. So let's look at this next question here. 39. Authority to make regulated government communications is derived from. Now, this is something that involves Canadian amateurs mostly. One of you guys would be the FCC stuff. But we have two regulations that make this. There's the Radio Communication Act, and then there's the Radio Communication Regulations that make the Radio Communication Act. Confusing? Yes. But anyways, authority to make regulations governing the communication is derived from the Radio Communication Act, if I remember correctly. Yeah. Inductive reactions may be increased by a decrease in applied frequency, an increase in applied frequency, a decrease in supplied current, or an increase in amplified voltage. Okay. Reactance. I believe that is an increase in amplified frequency, if I remember correctly. Yeah. That one I can't explain. That I just kind of pops in my head, the answer for that one. And thank you for still sticking around once I came back. I do appreciate it, guys. And hopefully you are finding this entertaining and as much knowledge as I can apply to you guys. I would also recommend check out Ham Radio Live. If you're interested in doing more amateur radio stuff, he does a lot more than what I can do right now. But like I said, I got some really cool events going on. Once I pass my exam, I'm going to do some POTA activations. I'll take you guys along with me. Won't be live though, but you guys can team up with me. Look at a couple POTA. Maybe we'll do like a live communications. Like when I don't go to a park, we'll just get on the radio and we'll make some contacts. Hey, wouldn't that be fun? I'm also looking at doing a 3D printing episode soon, talking about 3D printing and amateur radio. So if you guys want to see something like that, give me a thumbs up in the area. You know, you can also leave a comment in chat. But if you're watching this after the fact, you know you can always chat down below and let me know that way as a comment. Anyways, let's get back into this and continue the studying. A 75 ohm transmission line could be matched to a 300 ohm feed point of an antenna by using a 4-to-1 trigon, by using a 4-to-1 impedance transformer, by inserting a diode in the leg of the antenna, okay, with an extra 250 ohm resistor. So 75 ohm needs to match the 300 ohm by using a 4-to-1 impedance transformer. Impedance transformer could do the trick. In theory, I believe it's with the extra 250 ohm resistor, if I remember correctly. No, it's a transformer. I was right to begin with. I thought it was a transformer, but looks like I'm thinking impedance. I was thinking differently, I guess, in that sense. But it is one of those questions where this is more theory, and my theory isn't that great. So. Like I said, math and wiring is not my whole ball of wax, but I have built, but I can read schematics like night and day. So, which of the following is not correct? The ministry may suspend an amateur radio certificate whether the holder has failed to comply with the request and pay fees or interest are due, where the holder has conveyed the Radio Communication Act and its regular terms and conditions to the certificate, where the certificate was obtained through misrepresentation, with no notice or opportunity to make a representative therefore. Which of the following is not correct? Well, there are no fees for the Canadian amateur license. We know that already. Where a person has obtained through misread, yeah, that is correct. With notice or no opportunity to make a representation, therefore, I believe that is the one which is not correct, because you will be contacted if your license fell out of mistrust and everything else. D is correct. I don't know what you're saying. Thanks for Bruno, but yeah, glad you like my comments. Whenever there's a chance to whenever a change of address is made, A, the station shall not operate until the changes of address are forwarded to the Institute of Science and Technology. Science and Technology must be advised of any change in your postal address. You must notify them within 14 days of your new address. Within the same province, there's no need. Okay, so this is the government that abides by it. Kind of like with the FCC. If you guys move, you got to contact the FCC. So with me, I have to abide of any change to my postal code. It's going to be B if I remember correctly. But I can't remember if I have to do it within 14 days. But I believe it's immediately. Yeah. So if I was to move, say tomorrow, I have to let the government know I have moved or I changed my mailing address. Say I got a postal code. Say I got P.O. Box. Say P.O. Box 335. And all my mail has to go there. I have to tell the government my P.O. Box number. Because they need to contact me. They have to send it by mail. If you ground your station equipment to a ground rod driven into the earth, what is the shortest length of the rod to be? Oh, crap. 3 meters, 10 feet. 1.2 meters, 4 feet. 2.5, 8 feet. Now, a grounding rod has to be below the frost line. If I remember correctly, the frost line is 4 feet underground. So, a ground station must conform to the application's electrical code requirement. Your station equipment ground rod is driven into the earth. What's the shortest length it could be? It's a 4 to 4. I think it's more than 4 feet. Has to be below the frost line, which is 4 feet in the ground. So I'm going to say probably 4 feet. But I have a station ground must conform to the application's electrical code requirements. I think it's B. By knowledge, I'm going to say it's 4 feet, but I have a feeling this is what they're looking for. Yeah. So station ground must be conform to the applications of the electrical code requirement. So, guys, whenever you're grounding your station, you want to use a copper rod and you want to drive it into the earth as deep as you can, up to 4 feet. You should be below the frost. You have to go below the frost line. Something to also keep in mind. When you're driving a spike into the ground, make sure it's not near anything electrical or gas. You don't want kaboom, if you get my drift. Just something to keep in mind. Here's a key way to think about it. Electricity takes the shortest path to ground. Remember that. Shortest path to ground. And don't use like a pipe. If you got a pipe in your house and you're connecting it to your cold water, make sure it's not your actual ground. Also on top of it, don't attach it to any type of gas main. Please. Be smart about this. That's your advice from Ron today. Take it with a grain of salt. But trust me, whenever you're planning on putting up erecting a tower, make sure you do your research where your lines are running from. Just a word of advice. The wavelength corresponds to the frequency of 2 megahertz is 360 meters, 1,500 meters, 150 meters, or 30 meters. So for you guys that are, metric that aren't part of the metric system, 118.81 feet, 4,921 feet, 492 feet, or 98 feet. 2 megahertz. If I remember correctly, I believe it is C. We'll find out. Yeah, 492 feet. It just sounded right. I don't know why, but it just kind of said, yeah, it's going to be C. Okay. Okay. Let's test your knowledge, guys. I know the answer for this. What's the meaning of the Q signal QRS? Is it A, send more slowly? B, interfere from static? Send RST report? Radio station is located. Now, I know it's probably going to be which one it's going to be. QRS. But let's throw it out to you guys. QST is station location. So we know D is already ruled out. Similar slowly, I think it's QSL. I believe its answer is B, interference from static. Well, I could be wrong, but let's go with B. It's actually somewhere slowly. QRS. Oh, crap, man. I feel dumb. I goofed up. I thought it was interference from static. No, that's QRM. Yeah. That's QRM. That's interference. Yeah. Oops. Do you ever hear the Q signals a lot? Yes, you do. You'll hear them a lot more than you think. Can be an issue. What is the proper way to interrupt a repeater conversation to signal a distress call? Break in immediately following transmission of the active party. State your situation and call sign. Say help as many times as it takes for someone to answer. Say SOS, then your call sign. Say emergency 3 times. Well, you're trying to break, you want to break in their communication. So as soon as you hear a break, you pop in, you state your name, call sign, situation. It's going to be A. Depending on the wavelength of the signal, an energy densifies in the RF field and other factors in which in what way can RF energy affect body tissue? Now, RF means radio, uh, radiation frequency field. So when we send out signals, we're actually radiating our signal out. Something to keep in mind, here's a key factor to think about. Any energy that's not used is dissipated as heat. So RF tries to find the best way to enter into your body. So you got to be careful of RF. RF is dangerous and can kill you. But anyways, depending on the wavelength signal, the energy desensitizes of the RF field and other factors. In what way can RF energy affect body tissue? It heats the tissue. It causes blood flow to stop. Causes ionizing radiation poisoning. It has no effect on the body. Well, we already know it has effect on the body. What did I say about heat and energy? That's right. A. Let's see if it's correct. Let's go answer and then we got 50 more to go. I don't know if I got another hour and 30 of me. But anyways, practice exam question. Here we go. Where is interference to the reception of radio communications caused by the operator of an amateur radio station? What interference to the reception of the radio communication caused by the operator of the amateur station? The amateur radio station may continue to operate without restrictions. The amateur radio station is not obligated to take any action. The ministry may be required necessary steps to prevent the interference from being taken by the amateur radio. The amateur station operator may continue to operate the necessary steps to be taken when the amateur operator can afford it. I believe it is C. The ministry would have to step in to make sure that this thing gets taken care of, if I remember correctly. Yeah. An alkaline cell has a normally voltage of 1.5. When supplying a great deal of current, the voltage may drop to 1.2. This is caused by the cell's electrolytes becoming dry, internal resistance, current capacity, voltage capacity. I believe it is A, the electrolytes becoming dry. But we're going to have to check and see what it says. No, eternal resistance. Okay. Didn't know batteries had an eternal resistance. Holders of an amateur radio license certificate may be designed to build from scratch a transmitter equipment to use in the amateur radio, provided that the person has. Now, this is where it comes tricky. Because the amateur radio operator sometimes would have to have Morse code to do this. Because if he's building a beacon, he has to have that ability. Morse code with honor qualifications, basic and Morse code qualifications, basic qualifications, or advanced qualifications. While he's building the equipment, he has to be advanced. A circuit designed to increase the level of its input signal is called a receiver, an amplifier, a modulator, and an oscillator. Well, B, an amplifier. It's amplifying the signal. Pretty obvious. When may an amateur radio station in two-way communication transmit and encode messages? Message. When the transmission is above 450 megahertz. Only when the encoding or clipper is not sent. During a declared communication emergency. Or during contests. Is not secret. So what they mean is that, say, if everybody can understand what's going on, it's not a secret, then that's when you can use cryptic wording. In reality, amateur radio bands were not supposed to be crypted at all. So keep that in mind. According to the EM CAB-2, which of the following equipment is not used in a list of field strength criteria results of immune compliance? A. Radio sensitive equipment, broadcast transmitters, sorted associated equipment, or broadcast receivers. Radio sensitive equipment, if I remember correctly, it falls under that subject. It's broadcast transmitter. Okay. My bad. Why would it be useful to have an amusable world map center on a location of your station? It looks impressive because it shows the numbers of degrees, longitude, latitude of the amateur satellites move west. Because it shows the compass bearings of your station to any place on Earth for antenna planning and positioning. Because it shows the angle at which your amateur station or your amateur satellite crosses the equator. No, it's C. So you can use a compass to find my station. Just the way it is. So far we've answered 55. We got 41 right. So we do the math, just out of curiosity. Calculator. Okay. If I got 41, means we got 82%. Not bad. But I want to go for the full 100. And if I get over 90, I go write my exam soon. So let's see how I do. Frequency modulator receive. Okay, this is going to be fun. In a frequency modulation receiver, the blank is in between the antenna and mixer. The internal frequency amplifier, local oscillator, audio frequency amplifier, or radio frequency amplifier. Okay, it's receiving audio. The intermediate frequency amplifier. So this is between the antenna and the mixer. So there's something right there in between the antenna and mixer. It could be the amplifier. Because from the antenna, amplifies the signal going to the mixer to the output. Or is it the local oscillator? So receiver. So it's receiving signals. It's not sending signals. I'm going to say the amplifier. But I could be wrong. It could be the oscillator. Radio frequency amplifier. That's what they were looking for. Okay. I was close. It was an amplifier. But next time I see that again, I'm going to remember radio, not audio. Radio. If an amplimeter marked in amplimeters is used to measure 300 milliamp volt current, what reading should it show? 0.3 amplimeters, 3,000 amplimeters, 0.003 amplimeters, 3 amplimeters. I think it's 0.3 if I remember correctly. No, it's 3 amps meters. Okay. I know it was either 0.3 or 3. What kind of SWR readings may mean poor electrical contact between the parts of an antenna? A very low reading, a negative reading, no reading at all, or a jumpy reading? I would figure a jumpy reading would be the equivalent for that. D is correct. If you made a quarter wavelength vertical antenna for 21.125 megahertz, how long should that be? 7.2 meters, 23.6 feet. 3.6 meters, 11.8 feet. 3.36 meters, or 11 feet. Or 6.75 meters, 22 and 2 feet. I want to lead towards 23.6 feet, but I have a feeling that may be wrong. I'm not sure if it falls under the 11. Gonna go with D. I have a feeling I got this wrong. Yeah, it's C. 11 feet. Damn it. Oh well. Next. 60. What are RST signal reports? A short way to describe a sunspot activity. A short way to describe isophonic conditions. A short way to describe a signal reception. A short way to describe transmission power. I believe an RST is signal report. Yeah. What advantages of using a trap antenna? It minimizes harmonic radiation. It has a high directivity and higher frequency. It has high gain. It may be used for multi-band operation. Well, a trap antenna is used for multi-band for multi-band. $62. Wow, we're moving through this, guys. You need a current limiting resistor for high emitting diodes, LEDs, to actually resist may not be critical at all. Are out of the first below, which resistor would you select? Oh, they want 20%. Okay. What identification, if any, is required when two amateur stations begin communication? No identification required. One of the stations must give both call stations. Each station must transmit its own call sign. Both stations must transmit both call signs. I believe it's C. Each station must transmit its own call sign, if I remember correctly. Yep. That's what they were looking for. Which of these these common connectors have the lowest loss of UHF. An F-type cable connector, a BNC connector, an A-type connector, or a PL259 connector. I believe it's a BNC connector, if I remember correctly. No, type N connector has the lowest. Never seen the type N connector. The characteristic impedance of a 20-meter piece of transmission line is 52 ohms. If 10 meters were cut off, the impedance would be 26 ohms, 52 ohms, 39 ohms, or 13 ohms. Well, it still stays the same, if I remember correctly. Ohm's law. Yep, Ohm's law. Stays the same. Power line voltage has been made standard over the years, and the voltage generally supplied to homes is approximately 210 and 220, 120 to 240, 130 to 260, 100 to 200. I believe it's 110 to, say, 220 to 240. A regulated power supply, the blank is between the transformer and filter. Rectifier, output, input, regulator. Regulator, if I remember correctly. No, they were looking for rectifier. God damn it. I'm going to have to brush up on that. A receiver receives an incoming signal at 3.54 megahertz, and a local oscillator produces a signal at 3.995 megahertz. To which frequency should the IF be tuned to? 7.35 megahertz? 450 megahertz? 3.54 megahertz? 3.995 megahertz? No, looking at 455 kilohertz. Okay. Key clicks. Key clicks is the sparking of your key when you press down on it, and it's sparking by the power. So they're saying, how do you do this? By using a key click filter, by using a better power supply, by increasing the power by setting CW more slowly. If I remember correctly, it's setting it more slowly. Not a key click filter. No, it's a key click filter. That's what they were looking for. Okay. So I would have had that right if I went with my gut. But anyways, here we go. In single sideband and CW transceivers, the blank output is connected to the audio frequency amplifier. Internal frequency amplifier, product detector, beat frequency oscillator, or local oscillator. I'm going to use beat frequency oscillator. No, they're looking for a product detector. Now, these questions I find really hard and really stupid, so I don't know why we need to know the internals of a radio. I really don't get that. I can understand if it was more simpler, but throwing like, oh, it could be one of these items. That doesn't help. Okay, here we go. What would you connect a transceiver for voice operation? A splatter filter? A terminal voice control, a microphone, or D, a receiver audio filter? Well, you would have to have a microphone connected to the radio for it to do voice operation. Kind of obvious. Now, here's something interesting. What organization has published safety guidelines for the maximum limit of RF energy near a human body? Would it have been Environment Canada, Health Canada, Transport Canada, or Canadian Standards Association? It could be the standards. You know what? We're going to go with D. It was B, Health Canada. I should have went with B. Okay. 73. In transmission and transmitter, excessive harmonics are produced by low SWR, overdriven stages, linear amplifier, or resonant circuit. Overdriven. So overdriving, so say if I took the microphone and started talking really loud and muffling the sound, so it sounds like this. What you're hearing is overdriving the modulator, so you can't understand what I'm saying. And by shouting into a microphone, you're actually overdriving the stages for the sound to transmit. What semiconductor device has characters most similar to a triode vacuum tube? Would that be a junction diode, a bipolar transmitter, transcoder, a Zephyr diode, or a field effect transistor? I believe it's the diode. Nope, it is a field effective transistor. So let's see, what have I got wrong? I've gotten 49 of them wrong. Oh, nope, total answer 74, but I only got 49 right. 75. So we go calculator. If we take 49, divide that by 75. 65. So we've already failed. But I could get the rest of them right and then bring my number back up. Who knows? Let's go into this. Two resistors are parallel. Resistor A carries twice the current of resistor B, which means that the voltage across B is twice then across A. The voltage across A is twice that of across B. Half of the resistance of B, or B has half the resistance of A. Twice the current of the resistor. So, two parallels. Resistor A carries twice the current of resistor B. So that means A is twice as powerful as B. And they're in a parallel. Voltage across A is twice that across B. Half of that resistance, I believe it's C. Yeah. Why should you use only good quality coax cable and connector for a UHF antenna system? to keep RF low noise, to keep standing wave ratio of your antenna system high, to keep television interference high, to keep the power going through your antenna system from getting too high. Well, you want to use good coax. You want to keep the RF low. You want to keep interference low. Two basic types of bipolar transistors are an P and an N channel, NPN and a PNP. I believe it is this one right here. The NPN. Yeah. For radio signals, the skip distance is determined by A, the type of transmitting antenna used, the power field to the power amplifier, the length of the isotropic, and the angle of radiation. Angle of radiation. Well, the power that's fed to the power amplifier could have a feeling, but it's the height of the isospheric and the angle of radiation, if I remember correctly. Height is might, but it also matters on the field, as we already said. Certain signals will pass through the field, some of them won't. What effect does D region of the isospheric have on lower frequencies in the daytime? If I remember right, I believe it absorbs the signal. Yeah, absorbs signal. If two equal value capacitors are connected in parallel, what is their capacitance? The same value of each capacitor? Half that value of each capacitor, twice the value of each capacitor, or the value of one capacitor times the value of the other. I believe the value becomes twice the value of each capacitor. Yeah, twice the value of each capacitor, yeah. The operation of an amateur radio station who is the holder of a basic qualification shall ensure that their station power, when expressed as RF output, power measured across impedance matched load, does not exceed 150 watts, 560 peak envelope power for transmitting and producing any type of sideband emissions, 1,000 watts of carrier power for transmitting into other emissions, or 250 watts peak power. If I remember correctly, I believe it's 150 watts of peak power I'm allowed. Note they were looking for 560 watts envelope power for transmitting through any type of single sideband emissions. That's what you were looking for. Okay. What kind of amateur radio station automatically retransmits a signal from another station? That's easy. That's B. Repeater. It's repeating the signal. What is the maximum authorization bandwidth within a frequency range of 50 to 148 megahertz? 30 megahertz? Total bandwidth shall not pass or exceed the single sideband phone emission. The total bandwidth shall not exceed 10 times that of the CW transmit emission, or 20 megahertz. Oh boy, I forget what this is. I think it's the total bandwidth shall not exceed that of a single sideband phone emission. They are looking for A, 30 megahertz. Guys, just say kilohertz. Okay. 84. What should you make sure that no one can touch an open wire transmission line when you're transmitting with it? Oh, why should no one touch your wire? Well, that's obvious. RF burns. But anyways, because the contact might cause a short circuit and damage the transmitter, because the contact might cause spurious emissions, because high voltage radio energy may burn the person. Right there, there's your answer. D. You cook the person. D is correct. Can't you smell that barbecue? Yeah, I might touch the wire again. I was transmitting. Well, I have some fresh mic. There's a commercial. If you ever heard it, freshly milked Jeff, look it up. It is a bad commercial, but you get the idea of where I'm coming from with that line, with the freshly cooked Jeff. But anyways, let's go into this a little bit more. In frequency modulation transmitter, the input to the speech amplifier is connected to the what? Frequency multiplier, power amplifier, microphone, or demodulator? Transmitter. So we're speaking into the transmitter, so it has to come from the microphone, I would think. Yeah. Just makes sense. Property of an antenna which defines the range of frequency to which it responds is called front to back ratio, impedance, bandwidth, polarization. What's the answer? No, it's not bandwidth. Bandwidth is more like dealing with energy. Polarization, I don't think has that. A front to back ratio, I'm not sure that falls into, I think it's impedance. No, it was looking for bandwidth. Huh. Okay. A7. What antenna radiation pattern is for an isotropic radiator? Would it be a carloid, a parabola, unidirectional carloid, or a spear? I don't know. A carloid? I think. I'm not even sure on this answer, guys. I'm just going to take a stab in the dark. No, D, a spear. Okay. Currently, in an AC circuit goes through a complex cycle in 0.01 seconds, which means the AC frequency of 1 hertz, 1000 hertz, 10 hertz, or 100 hertz. I think it's 100 hertz if I remember correctly. Nope, 10. Oops. Which statement is correct? Any person may operate an amateur radio station under supervision and in the presence of a person holding the appropriate license qualifications. B, a person holding only a basic may operate the station on 14.2 megahertz. Any person operating a station in the amateur radio service, a radio amateur may permit any person to operate their station without supervision. Well, we know that one's wrong. It's going to be A. So if I'm holding a license, I can allow a person that's not licensed to use my radio as long as I am licensed for those bands. Something to keep in mind. If the center of impedance of a full dipole is approximately 300 ohms and you're using an RG 8U, which is a 500 ohms coaxial line, what is the ratio requirement to have on the line for the attendant of the match? It's going to be 2-to-1. Oh, 6-to-1 it wants. See, I was always 2-to-1 is what I would think it would be. When using mTOR transmitter, what are the two modes that may be utilized? Mode A uses automatic repeat request, ARQ, protocol, and is normally used for far communication, contact, and established when making general calls, when communication has been completed, at all times during mode B for test purposes only. That's for all communications once established. One Morse code qualification that is available for the amateur radio operation certificate is 15 words per minute, 7 words per minute, 12 words per minute, 5 words per minute. I believe it's 5 words per minute. Yeah, 5 words per minute. Which body organism can literally affect a very small amount of electrical current? Well, that's easy. The eye. Well, which body can be fatally affected by a very small amount of electric? Oh, that's the heart. Electrical current goes across the heart, you're dead. Yep. 94. Why should you pause briefly between transmissions when using a repeater? Okay, so in this case it would be C. We're almost done. We got 5 more questions to go. Trust me, I'm ready to go to bed after these. So we're going to do those, and then I am going to call it a night because it's already 11 o'clock Eastern Standard Time by my clock here. So we're going to answer these 5 questions pretty fast and get to it. So anyways, which of the following meters would be used to measure the power supply current draw by a small handheld transized receiver? A DC amplimeter, an RF power meter, electric voltmeter, or an RF amplimeter? Well, if we're measuring the power draw, current draw, we can use an RF power meter, I would think. No, electric voltmeter, if I remember correctly. Nope, DC. What type of propagation usually occurs from a handheld a VHF transceiver to another nearby? Skywave propagation, tunneling protocol, line of sight propagation, line of sight. Which isospheric region is closest to the Earth? The D, the E, the A, or the F? I believe it's the E. D region. Yep. If you let an unqualified third party use your amateur radio medicine, what must you do at your station control point? You must monitor and supervise all communication. Only if the contact makes frequencies below 300 megahertz. You must monitor and supervise communication if the contact makes countries which have no third-party communication. You must continuously monitor and supervise the third party's participation. You must key the transmitter to make sure the station identifies. No, see, you must continuously monitor and supervise that third party. Last one. Oh, no, 99. Then we got question 100. That's two. Comparing a digital dipole antenna they are directional radiation characteristics of a cube quad antenna. The quad is less directive in horizontal planes, but more directive in vertical planes. The quad has less directives in both horizontal and vertical planes. A quad has more directive in the horizontal planes, but less in vertical planes. A quad has more directive in both horizontal and vertical planes. I believe it has vertical and horizontal, if I remember correctly. Which of the following statements is not correct? Great, another one of these easy ones. Maybe. Shouldn't say that. I'm going to goof myself up. A person may permit the operation of a radio apparatus only when the apparatus is maintained to the radio communication spectrum tolerance rate. An amateur radio operator transmitting unnecessarily or offensive signals does not violate accepted practices. A person operating a radio station when the person complies with the standards operation station of the amateur radio band. Accept the certificate of amateur radio operator within the authorized amateur radio station allowed. No person shall possess, operate, or receive any purpose of amplifying the output of a license exempt radio apparatus. I believe it's this one, the offensive language one. Yeah. Okay, so we got 68 out of 100. Let's look at the exam and see what I'm not strong in. I got my propagation great. It's this one. 6. I did really bad in. So it looks like I'm getting better in assembly safety and this part, circuit components. I'm a little weak here, but I didn't do too bad. But right there is my fault. So I got to get a little bit better on my feed lines and antenna systems. So I got to work on that. But with that being said, not bad. I was actually expecting to get a lower grade than what I got. I am actually happy. Feed lines and antenna systems, I'm going to have to brush up on that a little bit more. But it's a start, guys. It's looking better every time I do this. But it's still a fail. You know, you can win some, you lose some. But anyways, out of all of it, I'm glad I've finished this all. We know where I'm weak. Going to take a picture of this, send it off to my send this off to one of my examiners, and see if he can give me any ideas or scopes or anything like that. But you know what? I feel good about it. Didn't do too bad. Time to brush up a little bit more. But yeah, I'm actually happy I passed the theory, my electronic in theory, but it's going to be feed line and antenna systems I need to brush up on this time around. But thanks for watching, everyone. Hopefully you enjoyed this. Hopefully it was entertaining. If you got any comments, like I said, type them down below in the comment section. If you're live, would love to see any comments. But once again, that's it for today. Thank you so much for watching. Have yourselves a great day. And I'll catch you guys maybe soon on the air. Bye, everybody.